with the presentation from Dr. Akem and Dr. Sophia. So we can start right now. Okay, so I'm giving the time
Paris,
to
by the
Prof.
way,
Teddy.
yep. By the way, we still have a small number of people. I think it's better to postpone for about 5 minutes. Is that okay?
I think it's okay. No, it's okay. It
Yep.
should be okay.
So
So okay, so as requested by Prof. Teddy, so we will wait for another 5 minutes for to other participant to enter the room. Ya, kita akan tunggu beberapa saat lagi dan mungkin dalam 5 menit untuk peserta lain untuk datang. Terima kasih. Thank you. To our third webinar, yeah, from University Nusa Putra, yeah, from School of Computer Science, postgraduate studies at Nusa Putra, University of Nusa Putra University. So we are welcoming two of our speakers, yeah, Dr. Akim and Dr. Sophia, yeah. So they will be speaking pathway of AI expert and systematic innovation. Ya, kita kedatangan dua tamu yang uh, sangat ahli di bidangnya, ya, yaitu Dr. Akim dari Malaysia dan Dr. Sophia dari Kambodia. Ya, mereka akan berbicara tentang pathway to AI expert and systematic innovation. Selamat datang juga kepada Prof. Teddy, ya, selaku Ketua School of Computer Science, ya, Nusa Putra University. Welcome, we are welcoming also Professor Teddy Mantoro, ya, as the Chief of School of Computer Science. So we will just start our webinar session tonight. And before we start presentation from two of our speakers, yeah, we will give the time to Prof. Teddy Mantoro to give an opening remarks. And after that, I will uh, give the brief information about of to our speakers. Yes, sekarang kita akan berikan waktu kepada Prof. Teddy untuk melakukan acara pembukaan dan lalu kemudian akan disambungkan dengan pembicara pertama dan kedua. Silakan Prof. Teddy, waktu dan tempat saya
thank you,
dipersilakan.
Dr. Haris, to give me a good time this afternoon, this Saturday afternoon, nearly night, by the way.
Saturday night.
Yeah, to give a bit a talk, yeah, to open this webinar. So first of all, I would like to welcome to Dr. Sophia. Thank you, Dr. Sophia, to join us tonight. And I think we met before, yeah, during the ICC ED, I think one of our conference before, and we invite you as one of the keynote speaker also at the time. And I really appreciate your effort also to introduce our webinar, and to maybe the next webinar we will invite also to forward also to you to let a couple students, for example, from Cambodia that can join us. Yeah, I got some information here that from Mr. Krang maybe that saying that couple of the students from Cambodia currently join us also. Really, really appreciate with that. The second one, he is my colleague for many, many years, Dr. Akim. He is also working in several areas. Sampat working together also with me. He was my PhD student long time ago, and I think we have a long experience also before, right, Dr. Akim? So really thanks for your time tonight that you can share your experience tonight. So everyone, we have like two interesting topics. The first one is about the AI career path, the AI expert. So we are going to hear directly from Dr. Sophea in the minutes, and then after that we'll follow by Dr. Akem. So Dr. Akem working in tracking before, user location, also in recommendation, also using AI. And also this time, I think he's going to share about the just a moment, I forget the titles here. The systematic innovation. Hopefully, will be directly to the area of the AI, Dr. Hakim. So everyone, for those who are already familiar with CIS, so thank you very much to join again the webinar, the third webinar. They collaborate between IEEE, the Computational Intelligence Society, Indonesian Chapter, and School of Computer Science, Nusa Putra University. Just for your information, IEEE-CIS Indonesian Chapter was created, was developed at the time in 2019. All right. So a couple people assigned at the time. So we proposed. I was lead this group to have the first what you call it, approval from the IEEE center at the time. So now we have already more than 250 members. You are welcome to join our members. A lot of professors actually in Indonesia who are working in AI area. They are joined in our WhatsApp group, for example. So really welcome everyone here. If, for example, you are not become the IEEE member, not registered at the CIS members also, Computational Intelligence Society, and you can join in our this activity also. All right. And every single years, usually between July or August, we have like a winter school. All right. Sometimes we call it also as the summer school, depend on who running this summer school, all right, or winter school. 3 countries usually join. One is CIS from Thailand. The leader was Mr. John, Dr. John, and then me from Indonesia, and the other one from Australia. All right. So 3 of us usually we arrange the summer school. Everything will be free, by the way. There is no registration fee for every single speaker. Also, we ask them as the volunteer. And really interesting school, everyone, the summer school, because you can meet directly, face to face, a couple people who has, for example, the age index, sometimes nearly 100. Okay, sometimes in Scopus, if you check his age index in greater than 40, for example, so we consider them as one of the strongest player in our area. All right. So you can join also by online, and then you can join also by physically come in directly. All right. This year we are still arranged. This will be happen, but still under the discussion. If not in Thailand, they will be in Australia. Really unfortunate for the last 5 years, it's not happening in Australia because of the transportation and so on. To go there quite expensive basically. So usually we choose goes to Bangkok. So then we meet directly face to face in Bangkok. All right. So that's the second one. The first one that's about the membership. The second one is about the summer school. The third one, we're running couple conference. CIS at the moment sponsor like 4 conference. And the first one they will be running in, actually the first one is not proposed by CIS, but we collaborate with the IEEE in Kuala Lumpur, all right? Because we're running this conference in Kuala Lumpur. So let me share with you in 1 or 2 minutes here before I finishing off my opening the conference that I just mentioned just now, all right? Okay, so this is my opening remark. The next one is about the conference. The 9 of ICCED to 2023 is already on progress. Yeah, they will be indexing under IEEE also. So everybody in this webinar, I really invite you to to submit your paper to this conference. It will be happen on the 7th until 8th of November to 2023. All right. And this will be held actually in the campus of Dr. Akem, the International Islamic University of Malaysia. Me and Prof. Media was there for Prof. Media was 5 years, and I was there for more than 4 years at the time in the university. So everybody, really, I invite you to join this international conference. All right. We are running 9 years, so this is the 9th times. And starting from the ICCED, the third one until now, it's already indexing by IEEE and Scopus. All right. The second one, this is the second one. This is running by Politeknik Negeri Jakarta. So this one about AI, trust, risk, and security management. Yeah. So these two conference, we're going to highlighting about. Sorry, this one's the old one. Yeah. The new one talking about the AI generative, basically generative AI. All right. So this one also we're going to discuss about the generative AI inside here. A couple speaker actually the CIS members, so you are welcome to submit also your work to this conference. All right. The third conference, this will be running on December. So if you see the sequence of the times, let me back again to here. This will be on the 7th until 8th November, still open by the way, your submission. The second one will be on the 14th until 15th of September. This is nearly close, by the way. All right. And then the third one, this will happen on the 20 December 2023 in Semarang, in the middle of Java. All right. We are in the finalization of the process to be registered in IEEE. All right. But for this already done, so everything is in the right path. So we are ready actually to running this. We are also already received a lot of paper inside here. Yeah, the IC2IE. This is the 6 times, and if you check here, I was the general chair for the first one, the second one, and the third one here. All right, as this the conference. So I really invite everybody here to join to this conference. If you see the registration, also if you working with the student, we put a big discount inside there. And the last part, this is related with the cybersecurity. This is running by the best university in Indonesia. They're working in cryptography, all right? Politeknik, Sandi, and Cyber Negara, all right? So cryptography and cybersecurity, really unfortunate, yeah, everyone. This already closed last night, so not accept any paper anymore. But if you really have very strong paper and you want to share, contribute to here, so I'm happy to give the channel to the committee, because CIS IEEE CIS Indonesian section was the currently as the sponsor of it. All right. So I think that's the couple update that I can share with you, yeah, everyone. The first one is about the membership. The second one is about this the summer school that we arranged. Everything free, but you need to book your own hotel. You need to prepare your own transportation. All right, but you're going to receive the certificate. Okay, just wait until the announcement happen. Okay, and then please remember also we still have the ID NNS, Indonesian Neurolinguistic Society. We have another society also, and in this coming December also they are running Iconic. So you are freely also. I'm not putting here the Iconic here because this is another entity. Yeah. So Iconic this year they will be the 31st times, yeah, for that conference. Okay, everyone. So as the closing remark from my side, this conference actually we have two objectives. Yeah, the first one is to sharing the knowledge. especially the area of AI, artificial intelligence, and also in the area of computation intelligence. And then the second one, of course, this is the personal or private aims that actually we want to introduce our school. So we want to find small number of people with the good brain, for example, then we want to invite them to study with us together. As everybody knows, in the School of Computer Science now already the 5th years, and we have a very good brain at the moment. They join with us. A couple big company actually sending their IT manager with us, and also some buddies, important buddies here in Indonesia. They send also their student to us, and we follow the ethic. For example, in cybersecurity, if people want to learn about the malware, we prepare all the lab and also all the expert basically. So they are going to learn with us with the good expert. But what I mean by ethic is we also select, really selected. Not everybody can join the type of class because we don't want suddenly the public, a lot of people in the public, they know how to create malware and then they spread out to the community and sharing the bad thing in the community. So we need to take care about it. And also at the same times in the AI side also we do the same thing. So what does it mean here? We want to protect our environment with the good thing. Then we select a couple of people when they want to working more deep in this area, especially in the AI and in the cybersecurity. So I think that's all for tonight. I think I spent like a couple minutes here. So with that, thank you everyone to join our webinar. Currently 70 people registered here will be joined with us. And then the first and the second of our webinar, we already spread out the certificate. This is for free, but you need to indicate that you need the certificate, of course, except for the speaker. They're going to send it to you directly because we have so many requests at a time. For example, nearly 100 from the first webinar. The second one also nearly in the same number. So please be patient. Because this is we do it in the voluntary basis. All right, so with that, again, thank you everyone. Please enjoy the webinar with us, and you are free to have any question also. So again, welcome to our two speakers, Dr. Sophea and Dr. Akem, and also thanks to the committee. Actually, the one who coordinate this conference, Dr. Dini, one of our lecturer, and also tonight as the moderator is Dr. Haris, also one of our lecturer also. So with that, again, thank you everyone. So wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, Prof. Teddy, for the opening remarks. Okay, so we are going to continue our next session. Yeah, the first speaker is Dr. Sophea Prum. So before Dr. Sophea will start her presentation, so I'm going to share with the participants some of her background. Yeah, Dr. Sophea is getting her PhD degree from University of La Rochelle, France. And currently she is a Vice Dean of Faculty of Engineering and Business Development Officer of the Camtech University, Cambodia. And also at the same time, she is holding the Chief Business Development Officer at Elite Figure Limited, Cambodia. So she will be speaking about pathways to become an AI expert. Yeah. So I will give the time this time to Dr. Sophia to proceed with the presentation. Please, Dr. Sophia.
Okay, selamat malam to everyone. Very good evening to everyone. Thank you so much, Harry, for your introduction. Thank you, Dr. Dini, for inviting me to this event. And good evening, Professor Teddy. Nice to see you again, this time virtually, after, I think, 4 or 5 years ago that we met in Singapore. Yes. Okay, so the reason why I designed these presentations on the pathway to become an AI or data science expert, it because most of the time when I meet students or newbie who want to pursue their study or explore in the AI or data science field, they mostly ask me where to start and how to study AI and data science. But of course, just a disclaimer, it's impossible to become an expert in AI or data science because each and every problem have its own challenge. We need its own solutions. So AI is very broad. This title is a little bit well overrating, but just to get attention. So the purpose of this presentation is to share with you my own design that I call it the 5 stack of knowledge to master your AI or data science expert. So yeah, just a brief introduction about me. So you can see on the other side is a little bit of my background, what I have been done. And yes, currently I'm the Vice Dean of Faculty of Engineering and also Business Development at Camtech University. Maybe just a quick introduction about Camtech. Camtech is a new university. It's a private but non-profit university in Cambodia that we focus on technology and science. Yeah, so to my working experience, so I mostly focus on AI, software engineering, business development, and also project management. All right, so let's just start to the questions. Since we talk about the pathway to become an expert in AI, so the first question is maybe what is AI exactly? Just for students, because some people, they may or may not know about AI. So we can see currently everyone use AI, but they may or may not know what it is. Taking a simple example, we all like taking selfie, right? So when you take a selfie, just a simple photo, you may notice that the photo that captured by your app is maybe, well, let's say more beautiful than you actually are, which is the truth. The reason why, because they have a bunch of algorithm running behind to clean up your photo without you even know about it. So when we call AI, it means a machine or system that can make its own decisions and do a certain task without or with minimum human interactions. Another example to make it easy to understand of what is AI, I think maybe everyone experienced with one of the entertainment app, which is Snapchat. So when you take a picture with Snapchat, it's allow you to actually Snapchat have automatically detect your face landscape and try to convert your face image to some other's design up to your choice, right? So with this, just for entertainment, so AI is used in our daily activity. So from entertainment to security, yeah. So the next question is why AI is important into this 21st centuries or in this era. Just maybe get back to the story. So nowadays we talk about the industry revolution 4.0, right? So just get back a little bit to this history. We have the first industrial revolution, which was on the end of 18th centuries. With the discovery of steam and water power that allow the industry to use this energy to operate their industry. The second revolution was on the early 20th centuries with the discovery of electrical power that we use it until nowadays. So with this inventions, it allow all the industry to it help in industry to have a better operation, so by using a device with electricity. The third revolutions, we talk about this automated production system by using information system and robotic. But with the third revolutions, we didn't talk about the so-called AI yet. So we do use technology to help in the industrial operations, but not intelligence, not in the intelligent way. So that's why in these 21st centuries, we talk about the fourth revolutions that we actually use 9 advanced technology, including cybersecurity, data science, IoT, VR, 3D printing, etc. But the main purpose of the fourth industrial revolutions is to automate the decisions using AI solutions. So in the fourth industrial revolutions, we use 9 technology, but the main purpose is to be able to do autonomous decisions by using the AI solution. So that's why AI is very important in this era. Okay, so a lot of people actually try to make the difference. What is the difference between AI and data science? So before we go deep down into the topic, I just want to highlight a little bit of what is the difference between AI, machine learning, deep learning, and data science. So when we talk about AI, but not data science, is when we talk about robotic in automation or reasoning, when we talk about image processing or video processing. But when we talk about AI, but not data science, is when we talk about data integration, the process of preparing data, data visualizations, data cleansing, data warehouse, etc. So those part is the work that we don't actually need this autonomous decision yet. So it's a preparing data process. But however, when we talk about AI, but also data science, because anyway, AI process data. So AI and data science is a brother. So when we talk about AI, but also data science, to me, is when we apply autonomous decisions by using machine learning. So the next question is, what is machine learning? The name explains what it is. Machine learning is the special algorithm that can learn from a bunch of data. And then we talk about deep learning, right? So the deep learning is just another type of machine learning that need a lot of data, very accurate. But until now, no one actually know how it works exactly, but it works. Yeah. Okay. So let's come to the topic. So how to master your AI or data science skills. So since AI and data science is for me, it's hard to find a boundary. So these two is going together. So those who master AI will master data science and vice versa. So to me, in order to master your skill in AI and data science, you need to master these 5 stacks of knowledge. So the first one is the domain knowledge. Of course, we cannot apply technology in anything if we don't understand this business model of each domain. So for example, if you want to apply AI into financial sectors of banking, so you need to understand how banking works, including even these law and regulations. So this domain knowledge, they have a few questions that we need to understand. For example, what are the challenges in the domain that you're going to work on? For example, if you are interested into financial sectors of banking system, so you need to understand what are the current challenges that you want to solve. And then the second questions will be, how do you want to overcome the challenge from this business perspective, but also from this technology perspective? And when we talk about AI and data science, we need data. Without data, we cannot do anything, right? So the third question will be, what data do you have? And if you don't have the data, it should be, how can you collect the data that you need? So that these all the 4 questions that you need to understand from each domain knowledge that you want to work on. Because AI and data science can be applied in any domain that you can choose in your interest. So whatever the domain that you want to work on, that will be the 4 questions you start before starting working on it. So the second step to me is the data preparations, because it's very important to fit this machine learning algorithm with the right data. And you need to choose the right data also. So in data preparations, we also talk about the data integrations, data cleansing, and data normalizations. And then to the next step, we talk about this machine learning. So we cannot do AI without machine learning, because machine learning is the core of the AI itself. So they have a lot of machine learning algorithms, so each of which have its own advantage and disadvantage, and each of which can be used in a different purpose, situations, and type of the data. So for machine learning, I will raise these 3 important knowledge that you need to know. So the first one is the advantage and disadvantage of each machine learning, because it is very important to choose the right algorithm for the right data. And then for the second knowledge, it will be this machine learning concept. We cannot choose the right algorithm without understand what it is and how it works, right? And then the last one, it will be the feature extractions or features learning. So if you use deep learning algorithm, it will be features learning. But if you use conventional algorithm, you need to understand how to extract features, because feature extractions play a very important role in this in your algorithm. It has a great impact on the accuracy of your system. And then come to the 4th stage of the knowledge is the critical thinking and analysis. So when you have your data and you apply your algorithm, so you need to know how to evaluate and understand why it works and why it doesn't work. So this is a 3 question to me is very important. So the first one is how to process your data. So you have your data, but how to process your data is also very important. So for example, you need to know if your data is a static data or if your data is the spatial or temporal data. So the way that you choose machine learning, the way that you select your data to process is very important. And then the second question is how to evaluate your result. Okay, so let's say you have your data, you will apply some machine learning, but if you don't know how to evaluate your algorithm and the result, so you don't know where is the problem and how to improve it. Okay, and the last one is trying to understand why, which is very important. So the why here is to understand why it works and why it doesn't work. So that's where you need to analyze your algorithms and also the result, and where you need to identify where to improve your overall of your system. So the 5th knowledge to me is the programming skill, which I always say be a full options researcher. So you may know how to use machine learning, you may know how to process your data, but if you don't know how to implement it, well, it's fun. You can hire an engineer to work on it, but to me, it's more fun that you can do it by yourself, or at least know how to do it. So the 5th knowledge is the programming skill. So you need to know what are the tools, libraries, frameworks, algorithm, and how to implement it, which is very important. So especially for students, when you learn AI or data science, so don't skip this part, because that part that have more funds and pens at the same time. Okay, so I will elaborate a little bit more detail on each step of this 5 stack of knowledge. All right, so let's go to the domain knowledge. So I can say AI is nowadays is a trend that can be used in any domains of your choice, of your interest. So they have also a research community for healthcare, for that, one of which is medical image processing. So AI and data science have been used a lot in healthcare industry. For example, I think Dr. Dini may be the one who can give a better explanation in this is her expertise, and we have an occasion to work together on some of the project also, like how to detect cervical cancer by using AI. Second one, yeah, agriculture. I think I don't know how it's in Indonesia, but Cambodia is a country that is based on agriculture. So applying AI in agriculture is one of our priority directions. Fintech. In Cambodia also, AI is one of, fintech is one of these sectors that develop a lot these recent years, that we start to use AI and other technology like blockchain to improve our fintech and also the transactions in the country. Traffic and transport, we can also use AI to detect and monitoring traffic. For example, when I was in Malaysia, we actually are working on one of the projects that trying to monitoring traffic flow by analyzing these video capturing at these junctions, and from that data that we collect, we can give a better advice to this Ministry of Transport to reorganize or develop of the certain segment of the road also to monitoring or reduce the traffic jam. Security, we also AI can be used a lot for security or even in the army development, and many more. So technologies, AI to be specific, can be used in any sectors and domain. So it will be up to your choice in which area you are interested in. Okay, so but the main challenge nowadays is the gaps between business and non-business and tech people. So for example, if we talk about and they may know how to overcome the challenge, but from business perspective, they may know what are the data they have, but they don't know how to use the data. They may know how to collect the data, but they may know what data they can collect, but they don't know how to collect the data. But from the tech perspective, we may not know what are the challenges happening in each domain, but we may know how to overcome the challenge by using technology. And we know how to leverage the data, but we don't have the data. And we may know how to collect the data, but normally we don't have permission to collect the data. So in technology in general and AI to be specific, they have always a gaps between a business and tech person. So the solution here is how to bridge the knowledge gaps, because that is very important. So to me, as an academic, it's very important to develop such a program of education and curriculum to integrate these two together. So just an example, for us at CamTech, our students learning not only from technical perspective, but also from business and entrepreneurship perspective, so that will help them to better apply technology to solve the business problem. But on another hand, for my suggestions is to integrate a certain course of AI or data science into non-tech major, for example, in finance, banking, or marketing, etc. So that in these centuries, to me, is better to go for multidisciplinary rather than go for a silo subject. Yeah, so that's just the short recommendation for the academic and education institution. So again, just to get back to this point, to bridge the knowledge gaps between business and non-business, the education institutions play a very crucial role here to teach and transfer knowledge to, at the same time, business people or business student and non-business student. Okay, so now let's come to the second point, the data preparations. So as we know that the machine learning, we heard the word, right? We are what we eat. But machine learning is we get what we feed. So machine learning is like a black box that you can put in the data. The machine will learn with a certain algorithm and then give us the output. So it is very important to prepare the data and to prepare to get or generate the data that are sufficient enough to train your machine, because very little data will make no sense to the machines. But the most important thing is to get the data that is close to the reality. So close to the reality means as close as possible. You may heard in a few years ago that some companies, I don't remember, they develop a webcam that can track people when they move the head, right? But since the data that trained or the technology was developed on Western face people, the Western people, or so they are white and have quite a different shape of face. So those technology cannot be applied in Asian or African people. And if you are testing in or using face recognition technology, you may try to use some pre-trained models. So most of the pre-trained models are trained on Western face. So basically, those algorithms, when we apply on Asians or non-Western people, we can see that the accuracy drop dramatically. So that is because of the data that they use to train. So that means the data that we train through the AI algorithm is not close to the reality. So it is very important here at this point to prepare the data that is close to the reality, and also to clean the data. So if you feed the algorithm with noise data, so the algorithm will learn with a certain bias also. Okay, and yes, so again, for AI is you get what you feed. Okay. So come to the questions. What data do you have and how can you get the data that you need? That is very important. So for the data preparation, we talk about 4 things. So the first thing is data integration. So that means in certain applications, you may need to collect the data from different sources. So how to integrate this data together is also one of the challenges in data preparation. Secondly, we talk about data transformations. So how to change when you collect data from different sources. So their format and structures may not be the same. So at this point, it is very important to do these data transformations to change the format and structures into a standard one. And the third point, we talk about data cleansing, because some data may have noise or corrupted. I will clarify about this point a little bit later. And then the third one, we talk about data normalization. So that comes to these 2 points. I will just give an example. This data set I was collected from the online is the data set to evaluate this wine quality. So how to evaluate wine quality? They may use like 10 or 11 features of a chemistry component into this wine set. But if you look into this data, we can see they have an incorrect null values here for some reason. So the data is not clean. In case you need to correct these values. So they have many ways to correct the values, but can give 2 examples here. So whether you decide to remove this record or you decide to correct this record. So they have different methods and technique to do this also. Okay, I will not go into detail, but the purpose of this presentation is to give you the highlight, but then later on, students may be able to explore a bit more or further in detail for each step of this 5 stack of knowledge. And when we talk about normalization here, you can look into this chloride. You can see the values go close to 0. But on the other hand, if we look into the dioxide, the values are much higher. So if you feed this data directly to your machine, so the algorithm will likely have a bias toward the dioxide features. So in this point, it is very important to normalize and put this data into the same range. So normally we use this method either to normalize or standardize the data. Okay, if you don't understand these two keywords, it's fine, but still have time to take and learn more detail, further in detail. Okay, let's just come to the next point, which is the machine learning. So machine learning itself is not news. I will just give a brief history here about machine learning. So we start to use machine learning, but back then we call it pattern recognition. But of course, in pattern recognitions, machines are not learned from the data yet, but they learn about the pattern of the data. So that's why we call it pattern recognition. So it was happened since 1970. It's around 1970 and 1980. We use pattern recognition technique. And then around 1990, we talk about this expert system, where we try to develop a system to have a certain intelligence, but by using the emulating decision-making ability of a human expert. Okay, and then around 2000 to 2005 is the rising of the machine learning algorithm. So they have a lot of algorithm at that time have been developed and released by researchers. And between 2005 and 2010, we talk about this. This is the machine learning era that we start to widely use machine learning algorithm tools to apply in research. But at that point, this research is not quite successful yet. Very little numbers of algorithms have been used in the industry. But then, starting from 2010 to 2015 is the rise of deep learning and machine learning, or we call it another word is the hungry model, where machine learning is starting to be better and smarter. So at this point, we start to have a lot of machine learning based or AI based system applied into the real industry. And then from 2015 until today, we start to have a much smarter learning strategy, including this adaptive model that can learn with a small data set and using adaptive learning strategy and so on. Yeah. So if we talk about this point, we classify this machine learning algorithm into two categories. So either the conventional machine learning algorithm or deep learning algorithm. Yes, so one of the dream of all the AI researchers is to be able to create AI system that can create another AI system, which is to me is not impossible. And we just, yeah, waiting for the time to come to this point. Okay, so when we talk about machine learning, so the goal of machine learning is to first trying to develop a certain algorithm that be able to minimize the distance of the intra-class sample and maximize the distance of the inter-class sample. It may be quite difficult to understand. The words are very similar, but for students, but I hope that this slide can be shared to students and you can do further research to understand each of the points. So what you have to know about machine learning. So again, first you need to know this concept of machine learning, how each machine learning works and what are the concepts. And you need to also understand the advantage or disadvantage of each machine learning, because each machine learning may be designed for a certain purpose. And also you must know how to process your data. Okay, and this is just an example. You can have a detailed look. So when we talk about machine learning, we talk about unsupervised learning, supervised learning, and reinforcement learning. So under this unsupervised learning, we talk about clustering and dimensional reductions. For supervised learning, we talk about classification and regressions. And then we have this reinforcement learning that allow the algorithm to learn on the real-time decisions. So normally we use it for robot navigations, gaming, and so on. So these are a few algorithms that I can listing here. Again, you can dive into each of the algorithm and learn about that, but they have much more than that. This is just a few examples that I can list down here. Okay, Again, when you apply each and machine learning on your data, so you must understand the concept, you must understand this advantage and disadvantage, and also understand your nature of the data. So if you apply machine learning without understanding these 3 points, this may be what you can get. Yeah. Okay, so let's move to the 4th point. Once you apply your machine learning on the data, you must know how to evaluate the result. So the purpose of evaluations is to be able to understand why. So why your machine learning work and why it doesn't work, that is very important. So to do evaluations, normally you need 2 things. So the first thing is your data benchmark. So the objective of your data benchmark is to create a standard data set to evaluate your algorithm. And your data, again, must be close to the reality. So as close as possible. And then we talk about the evaluation metric. So that will be depend on the algorithm you use and the purpose of your AI. So it can be confusion metric, it can be F1 score, it can be AUC, area under ROC curve, and so on. So they have plenty of algorithm here that I won't have time to listing down or explain in each and every detail of the algorithm. But again, the algorithm must be chosen wisely, depend on what you want to develop and what is the purpose of your machine learning applications. So coming to the programming skill, again, you need to be a full option researcher. That is my favorite words. So you can use C programming language, Python, and R. So R normally used for data science. Or MATLAB, but well, rich people use MATLAB because MATLAB is not free. C, Python, and R is free, and they have plenty of libraries and tools that you can use. And coming to this, I just want to list down different tools, one of which is Weka. So Weka is a tool that has been developed long ago. It's an old tool, but I still like to use it because it's allow, especially for the beginner, to explore a little bit on how your data are distributed and to allow you to experiment algorithm without even doing programming. So it helps you to understand or testing how each machine learning work and get some result on your data. But again, this is a tool, so it won't help much on develop a new tool, a new creative, but it helps beginners to start learning and understand and try to explore your data. And OpenCV is the libraries that available in C++ and Python that have been largely used for computer visions and machine learning, but recently they have a lot of others tool integrated with OpenCV because OpenCV is an open source, so it developed very fast. Up to now, I think it go to version 3 or 4 something. Yeah, when I was it was 2. Okay. PyTorch is a framework based on Python, CUDA, C, and C++. So you can choose your favorite language. But PyTorch is normally used for machine learning, NLP, natural language processing, but also computer vision. And then you have TensorFlow. So TensorFlow is a library. It's the most complex library, but very complete, that is used normally for deep learning. So it's TensorFlow was written in C++, but you have wrapping to Python, so you can use TensorFlow from Python. So it normally used for machine learning AI, but it focuses on developing deep learning algorithm. And then you have Keras. So TensorFlow is quite complex to use, especially for beginners. So that's why some good people have created Keras. So Keras is a library based on Python, and it acts like an interface to connect to TensorFlow. And later on, it also supported connective, Chino, and PlatML. So they have a lot of things to explore with Keras also. And yeah, of course, there are many more, maybe out of my knowledge, but all these tool and library are the tool and library that I myself have some experience on it. Okay, so to summary again, to expert in AI, you need to master these 5 domain of knowledge. So first one that I call it the domain of knowledge. Second one is data preparations. Third one is the machine learning algorithm. Fourth is the critical thinking and analysis. And the fifth one is your programming skill. So AI is fun. So just start from a small thing. AI theory and mathematics can be a bit complicated, yes, but you can just play to learn. For example, you can just start with playing with some OpenCV functions that help you to explore from programming perspective, but not mathematical perspective. But later on, when you are comfortable and start to like it, then you can go a little bit deeper on the mathematical equations and what happening at the back and in the core of machine learning algorithm. But the last question is how to be great in AI. So for me, is getting started with it, work hard and work harder. So that just the recommendation normally I give for students. Okay, and just to finish this presentation, so it is almost impossible to become an AI expert because AI is broad and each and every problem are different that need a custom design of the algorithm. So I myself cannot claim myself as an expert. So I know just only the work I work on. But we can learn and take part of the journey because AI is now in the future. Okay, that's all from my presentation. Thank you so much.
Yeah, thank you so much, Dr. Sophia. And thank you for the presentation, and which is very enlightening, and I think it's very good and very extraordinary. I think, Dr. Sophia, and you can give an inspiration to others to be an AI expert. Thank you, Dr. Sophia, for nice presentation. And I think maybe those who are coming to this webinar, maybe you can join with us at the Nusa Putra University, so that you can learn knowledge and all the courses related to the ICT, especially to the AI expert. Maybe Dr. Sophia can be one of our guest lecture later on.
Thank you. Thank you.
Okay.
Thank you so much.
Yes. Yeah. Okay. Now, maybe we will combine the question and answer session after the second presentation. Is it okay for you, Dr. Sophia?
Yeah, sure, no problem.
Okay. So,
Thank you.
okay, to first. Okay, so now we are giving the time to Dr. Akem. Hello, Dr. Akem. Are you here with us?
Yes, I'm here.
Okay, thank you so much. Yeah, so the second session will be given to Dr. Akem. Yeah, and maybe before we give the time to Dr. Akem, maybe I will just give some brief introduction about him. Yeah, his complete name is Akem Olowolayemo. I'm sorry for misspelling. And actually, currently is assistant professor and academic advisor at Department of Computer Science at the International Islamic University Malaysia. And he was getting his PhD from the same university, yeah, from the same department. And just I think at the very beginning, Dr. Prof. Teddy has also mentioned about he was under supervision of Dr. Prof. Teddy. Okay, so we are going to give the time to Dr. Akem and to give the presentation about systematic innovation. Yeah. So you may start your presentation now, Dr. Akem.
All right.
So please.
Thank you very much.
Tafadhal.
And a very good evening to everyone. Thank you very much to Prof. Teddy, who was my mentor, for giving me this opportunity to share a little with Nusa Putra, master student in IT or computer science. And also thank you to Dr. Dini, because she's the one that actually informed me of this webinar. And all the staff, Dr. Harris and everyone, I really appreciate the opportunity given to share. So Prof. Teddy, when you mentioned about me a while ago, he said I was in location and tracking. That was my PhD. But I'm still in artificial intelligence, okay? So, and what I will be discussing actually is artificial intelligence, but innovation techniques generally can be used for any area of life. So I will still, in my outline, I think you will see that it's going to be related to artificial intelligence and how I want us to, a broader look at what we have. Dr. Sophea has actually helped me a lot because she already gave a lot of background that I will be referring to as I continue. So I'll be hanging on that as we continue. So my outline, as I have it here, is I'm not sure if we have heard about trees before, so I want to give kind of introduction into trees, some of the philosophies and the ideas, and also highlight the level of solutions to problem. And then eventually I would like to see how we can relate that to future AI applications. So those are the outline that I have. So briefly, even though trees is wide, but briefly, I would just like to say that TRIZ is Theory of Inventive Problem Solving. Is an acronym from Russian. So the title, the keywords is actually Teoria Rezhenia Izobreta. It's a very difficult name to call, as at the bottom of the slide. However, when you translate to English, it is Theory of Inventive Problem Solving. If you notice, Dr. Sophea mentioned about critical thinking. Eventually, when you want to decide on your AI applications, like, okay, so this algorithm is better than this one is the most efficient, how to determine all this. So critical thinking is really very crucial. But TRIZ was invented by Altzuller, Heinrich Altzuller. Is a very long time ago. He passed away in the 1980s, but after that, a lot of development have been added to TRIZ from so many areas. What did he do? He was a young, as you can see, he started at the age of 14. So he was asking questions from experts that how can you be a good innovator? How can you solve problems easily? People said you just have to be gifted, you just have to do it, and then you find out whether you can solve or not. He was not satisfied. So he felt that when you want to solve problem, there should be a way to be an innovator. And I remember Prof. Teddy, the first class in advanced mobile computing class, one of the challenges he gave to us is to differentiate between creativity and innovation. So most of us, when you ask, are you innovative? Are you creative? People don't want to, they don't see themselves as creative. They believe that creativity is given to some genius or some people who can do that. But the reality is there could be a systematic way to solving problem. That is the hypothesis from Altzuller, and that is what he actually developed. So what did he do? He tried to look for all the patents he can get and try to study how they invent all the patents at that time, because it was a long time ago. he had to look at the patent, reads patents. It's difficult to read patent actually, but he did. He read over 200,000 patents. And from those patents, he was trying to summarize ways to solve problems. Okay, so that it can be easier for people to understand how to do that. So first, it started with 200,000 patents. Now we have a lot of patents, more than before. So a lot of patents have been analyzed and then improved upon. So he analyzed 200,000 patents and then reduced it to 40,000. Like the first 160,000 thereabout patents are not really good. They are just repetition or something that is not really special. So he reduced it to 40,000, and then from the 40,000, he developed method of solving problem. This method, we summarize it generally into three. One is 40 inventive principles of solving problem. And second one is a trend in technology. Like if I know today, this is the device that I have, I can always tell the next device that will replace that one. So that is the second one. And then the third one is scientific effect, that if you want to solve problem, there is a database of ideas that you can use to solve problem. That is what TRIZ is all about. So generally, maybe I will just go faster about some of these things. We know that generally it is easier to invent when you are younger than when you grow older. As you grow older, you have more experience, you become expert in knowledge domain, then you are stuck to a way of thinking. So it's difficult for you to actually use other methods. But when you are younger, you can try so many things, especially when you are still very young. So these are some of the problems. So how to re-engineer creativity, that is the idea here. So the first problem in solving problem is the one that I just mentioned. We call it psychological inertia. It's a way of solving problem that we are used to. So we don't want to try something new. We are always focusing on one way of solving that problem. Even if you are going home, there's always one road that you take to your home, and you don't want to try other roads, even though those roads are possible. So many ways, so many easy problems, we solve it in complex ways because that is what we are used to. So we call it psychological inertia, meaning that you are stuck with a method of solving problem and then you continue to focus on only that way of solving problem. That is psychological inertia. And there's so many analogies that have been given to it. They said it's like if you are given the opportunity to go and mine gold, okay, when you get there, you want to go to where the people have already started. They have digged some hole, you want to continue to dig the same hole. And this is what people continue to do. But the best thing will have been to evaluate in a different way to find the best hole to dig. But normally, mind of human will always go to a solution that is already existing, the same way of doing things, and then they will go and continue to solve that way. So briefly, so that we know that TRIZ is not, it may not be popular among academics. Now it's popular among academics, but in so many industries, they use it to solve problems. We know about Six Sigma, we know about all of them. TRIZ is one of the unique toolbox that they use to solve problem. As you can see here, you will see that Samsung, when they started to make a lot of profits, TRIZ was one of the major reasons that they made a lot of profit. And they mandate all their teams to actually learn how to use these techniques so that they can solve a lot of problems. Just to put that out there, so many companies, a lot, they are using TRIZ to solve problems. And also all around the world, around us, there's even, I believe in Indonesia, there will be TRIZ team because in Malaysia we have matriz. I believe Indonesia will also have. It can be applied to almost anything that we know. So now, what is the first hypothesis? If we want to solve problem, there will always be a similar problem that has been solved before. It may actually be in something that we don't think about, maybe in our culture, maybe in heritage, maybe in our stories of the past, fables. The problem that we want to solve now is already solved, probably. And if we are creative enough, we can find the solution that is already there. That is the first hypothesis. It's not all the time, but most of the time it will be like that. Okay, and examples in the past. This is an example of somebody who got Nobel laureate. Why? Because she looks at the tradition of Chinese medicine, and then from there she developed a new antidote for malaria, and that is what she actually got the Nobel laureate for. And you can see this aged man, his name is Jakub, in Africa as well, who developed something that many professors cannot do. Thousands of professors cannot do what he did. He did not go to school, but he got an award from the UN simply because of this, because he used something in their tradition that is already there. So that is one principle in trace, that what you want to solve now, by chance it has been solved before, or somebody has given the idea ahead of time. Most of us, if we are familiar with old Malaysian drama, we will have seen this one. People said, perhaps, maybe this is the first augmented reality. She was looking at a picture and the picture started to talk to her. So some of us will have seen that it is online. I put the link there so we can actually see that. So many ideas have been there. We can use those ideas to solve problems if we pay attention to them and we don't focus only one way of solving problems. Another thing that we try to emphasize is about focusing on our strengths. Sometimes, I'm going to emphasize this one a lot. Sometimes we want to do things that the experts are doing, and eventually we just do a little bit like them, but not achieving anything. So if we focus on our strengths, we will do more. So we need to really know where we are good at, where we can actually make a mark, and we focus those areas. So because of time, so what is unique about trace? If we are using every method of solving problem, most of the time we use, for machine learning, most of the time, machine learning is more of black box. Most of the time we use try and error, we run the algorithm, we try again and again and again. And that is what we do all the time. But it's still okay because there is no alternative to that. We still continue to run the algorithm and then compare the accuracy, compare the balance accuracy, the whatever metrics we are using to evaluate it. We will get solution, we may not. So that is why trial and error is like that. It can diverge, it can converge, it can go to local minimum, local extrema. So it depends on the solution. The structured way, it depends. If you are using brainstorming, for instance, brainstorming has a strong weakness that when you are solving a problem, the one that talks more seems to be the one that has a lot of idea. So if it's going in the right direction, then maybe we will get to the solution. But if it's not in the right direction, possibly we will go in the wrong direction. So if the solution is going towards, the solution is on the right, and if it's moving in the wrong direction, then we will diverge out of the solution. What TRIZ is trying to do is to guide everybody in the direction of the solution. No system is perfect, but that is the idea. using functional analysis, cause and effect, trimming, SCOP. I'm going to mention a few of them as we go. So when the basic concepts of phrase that maybe from today, if we are actually hearing this for the first time, that I may want us to remember is these four. Apart from psychological inertia, which means that when we are solving problems, we have to know that our method of solving problem does not mean that is the best way of solving it. So it could actually be a better solution is there. Okay, so the first one is ideal solution. Ideal solution or ideality means that if you want to solve a problem, there will be a standard way of solving that problem, maybe in another domain, but it's already existing. You just have to find it. It will become easier for you to solve problem. Secondly is we have what we call contradiction. Contradiction means that when you are solving a problem, one problem is being solved, another problem is being introduced. Something is going better, something becomes bad. Okay, so if we have contradiction, what we do in most problems solving is to do trade-off. We look at which one do we prefer? We want this one to be as much as this one. We downplay the problem. But in trees, the solution is to remove completely the contradiction. And there is a list of methods to solve the contradiction. Another thing is resources. Every one of us, every university, every department, every country, every community, you have a lot of resources. The more you use your resources, the better. That is the principle of resources. The less you use your resources, that is the extent to which you are going to be successful. Resources is actually there with us. Time is one of them. Access is one of them. Connection is one of them. What we want to use it for is what we use it for. Some we ignore, some we don't even know we have. So resources is really crucial. Many times we have the resources around us, we just don't take note. And then we have system approach. When we analyze a problem, every problem possibly already have the solution around it. So the solution may actually be around the problem that we want to solve. So I will not go into so much detail. I gave examples here, but I'm worried because I think I talk too much sometimes. So I want to limit, maybe if there's another time, I hope if what I share is good enough, maybe we can actually come back to it. So I will just give an example of contradiction so that we can see. In devices that we have created, if you see your mobile phone is very small. And okay, so the contradiction there is we have small size, but we want more tools, more applications, okay? The techniques in trees that was used to design that is separation in space and time. So if I need the keyboard, it will come only when I need it. If I don't need the keyboard, my phone is going to be flat. Nothing, nobody will know there is keyboard there until I start to use the keyboard applications. So that is separation in time. As you can see, you have a lot of icons. They will not be available until you want to use them. That's just an example. As you see, you will see a lot of them. The reverse one, you want to move or you want to stay in the same place, you want to run, still you want to be in the same place, and so on. So the same, all these are possible, separation techniques and so on. I think I should skip all this one. Now, the next one, which I think I should highlight is there is a general evolution of, this is where I want to relate to AI actually. There is a general evolution of system. We know what we have today. We should be able to predict what we are going to know, what we are going to have tomorrow. So if you have a system today that is first of all, you have so many in this particular one. This is dashboard of cars. Okay, the first one, there's a lot of meters. Okay, you have for speed, you have for fuel, and so on, and then it become combined, and then it will disappear, and before you know it, it's going to be signals instead of maybe augmented reality instead of so we can see the evolution. If you look at keyboard, mouse, and the rest of them, you will see the flexibility will continue, and then until it becomes fluid. It can become from solid, liquid, or gas, and then it become. So we can always predict what is going to be the next one. So as you can see, this is an example of doors. Okay, before you will see the door is rigid, you have to open it, and then it becomes two, and then you can. Now before you get to the door, it can move by itself. Sometimes maybe the next generation of doors, which most likely is you don't even need to. There's no door until you get there, and that is actually possible. We can see a lot of evolution, and I don't want to. So this is another one which I think everybody will relate to. We used to have trolley, and we have bags, and we can combine the two. And we have bags that you can push, and now we have bags you don't need to push. So we can know the direction that the next system is going to be if we look at the future of that system. So what is the level of innovation that Altzuller was talking about? He said that most of the work that we do today is not really contributing much to anything. So if we do level 1, it is something that is already known. If I take some images, samples of some images online, analyze it, use several algorithms, and then come up with some result, we already know how the result is going to look like. So even though I'm using machine learning, use new algorithm, in fact, sometimes I may use deep learning, and the result may not be better than the traditional ML. So these are some of the examples. So improvements, it could be an existing system that we just improved a little. The third one, at least, we are using ideas from another field. Maybe then we can come out with solutions. So most of the time, the invention that will come is in level 4 and 5. Okay, and if you look at this one, if our final year undergraduate student, our master's student, our PhD student, if their research is actually innovative, we'll be in level 4 and 5, and we'll have a lot of patents. Even if level 3, we should be able to get patents too. But most of the time, what we do is we recycle what we already know that is going to happen. So that is the idea that we have in the levels of innovation by. So if we want to change our systems, what are the things we need to do? There is a huge gap. This picture, I look for a picture that I can use to demonstrate this. From our universities, whether undergraduate, masters, or PhD, there is a huge gap from what we do in the university and what they do in the industry. Most of the time, the target is we finish, we get our degree, and then we get retrained in the industry. And that is not possibly good enough. So how to create this bridge to actually join the industry to the academics? This is the idea. Okay, I think this one, no, okay. What we notice, from this perspective, is that most of the time we focus too much on publications. It's good to publish, but as you can see, if you look at this cartoon, even though it is simplistic, I see journal articles, patents, legal fields, and then nothing, which means that most of the time, what we do will not actually be used for anything. We just continue to recycle what we do because that is what we are used to. Prof. Teddy already told me the first paper that I published, he said, you have to remember, Akem, when you want to publish, ask yourself so many times whether you are wasting the time of people who are going to read your papers or not. So as you can see, this is what this is actually talking about. When we want to publish, we ask ourselves so many times, is this actually contributing, or just because I want to have a paper out there? Yeah, that's the thing. It's good to train people. We need to train ourselves, our students as well, on how to publish. But we need to actually ask questions beyond that. Why do we publish itself? So I think, and if we stay with what I just mentioned, you will see that we stay from research to knowledge, and we don't even get to whatever the industry, the impact, whatever it is, we don't get to there. That is what the problem is, actually. So yes, this is the model that I created last year about how to use TRIZ method to change our curriculum, especially computer science. So I was looking at year 1, 2, 3, okay? And then I look at year 4 also. I want us to be able to bridge the gap between our undergraduate and the industry. And when I look, I use ideality, I use streaming, I use universality, and a few other combos in TRIZ. I was trying to search for the best, most rigorous training that has a lot of practice. Most of the time, our students come to our class, we talk to them, they go back to their hostel, we give them assignment to do. But which profession, which field give a lot of practice or they practice with real life to their students? So when I search, eventually I pick medical school. So what this idea is all about is I want to redesign our curriculum in such a way as the medical school, such that students will do real life applications instead of class applications. So if, for instance, I want them to design an AI to do something, they will do it for a company, or they will do it and sell it. That will make them to actually do it for real. That is the idea here. So we can, the year 1, year 2 will be combining all the courses that we have so that the courses can be, can join together, okay? And then immediately they get to maybe year 3, year 4, they should be working as a member of the service center for the university, which is going to be more of R&D, not lab. If it's lab, it's still classwork. But now it's going to be something that can be used in the society. So this is the analysis that I did on the medical school, so that I don't take too much of our time. So if we do that, the computer departments, for instance, we can do it for other fields too, but at least since this is our class, the first one that we'll do is we'll have like R&D units that is going to design applications that will be used by the industry for real. That is the purpose of this idea. And to be able to understand this very well, we need to look at foresight. If we don't look at the future, we will not design good applications. Applications that we have now, we already know. But the future of those applications will give us the motivation to actually create what we need. If you look at, we have a lot of possible futures. We know what is probably going to happen, but we must actually be involved in the future itself. So if we want to create that future, then we have to be involved. That is what the foresight is all about. In the next few slides, I'll be taking from this future created by ITR just to use it as my explanation. So future, I think maybe because of time, I just skip that. But the most important is that if we want to have a future, we want to make it happen. We want to create it. So like in Nusa Putra master's program or PhD program, we should have like a future center. Prof. Teddy used to have intake here in IUN. So if I'm given the opportunity, I will create a future center where we will look at AI applications. If we pick smart farm only, the student will not just go and get images of tomatoes, images of pepper, analyze it. They will do the application from the beginning to the end so that they know. I mean, it doesn't have to be, maybe we focus only a few, but what I would think we should do is that we should actually make sure that an application that we develop will be used. Ready to be used, kind of. So this is what this is all about. So if we have autonomous factory, if this is what we want to focus, then let's do it from the beginning to the end. And get, most of the time it's possible, possibly, maybe we need companies to sponsor as partners, but if they don't sponsor, the best way to teach our students to really do it is to use real life applications for them, not people thinking of an idea, they go and do it, and then they give us the result, and then they write the paper, and then that is the end. If we do that, they will have general ideas. If they work in good places, they will develop it. But if we really want them to be as creative as possible, we need to take a step further so that they can complete the life cycle of an AI application. Most of the time in papers, what we do, we present the results of the algorithm, we show the data, and then that is the end. What we should see is a complete system that actually functions. So AI, military strategy, we have a lot of applications that we can actually point to. For instance, some of the future applications that they mention here is that in the future, it is possible to get all the experts in particular field to treat a patient so that they can gather ideas together using augmented reality or any other way. Do we have students? Can we train ourselves up to the point of developing an application to that extent? So we should start thinking along this direction. Disaster recovery. Prof. Teddy, I think you still remember we have a paper like this that actually talks about how to dynamically locate people stranded in buildings. Okay, even though it was just a paper, we were not able to do it to the end. So here you will see it is combined with drone technology, combined with locating everybody in the building accurately to be able to rescue them. So these are some of the things that we can actually do. Most of the time we do it bits, and then we leave. Some of these applications, I think it is time for us to actually complete it. Once we complete, we will know all the problems. We will know the cyber security, the threats, the security problems, the software development, the interface problem, the integration problems that we have there, and then the AI components that we have there. Most of the time we focus only AI, very small, even though the algorithm takes a lot of time to train, but that is the only thing we are going to do. How it is deployed into special applications is difficult for most students because they don't do it in so many of their trials. So I think with that, I think I should. Okay, so we have career platforms, so many augmented reality, AI embedded in so many systems are coming, and which, if we use foresight and we look forward, the next stage of all those applications, we pick a few areas, especially because we need a lot of smart students and ourselves to actually work in this area. So we need to look at some of these things and do it, fully, instead of waiting for later when they get to the industry, maybe they know how to do it, maybe not. So what I talked about generally, so to round up, is I introduced trees and talk about the main philosophy and mention the levels of solutions. The level of solution is emphasizing that most of what we do is a repetition of something that is already there. If we really innovate, then it becomes a patent. So that is, if we can find a way to resolve that, we'll have a lot of patents. every FYP, every master's, every PhD will become patents, actually, if we really do something very new. And then I talk about future applications of AI, that we have to look at the future to solve some, to really train our students in this direction. If we want to solve a particular problem, then we work in groups. A lot of the students will work in groups and solve a problem completely. If we are able to solve it, we can make a lot of money actually for schools in these areas. So these are the my submission. Thank you very much for this unique opportunity. I hope that I've said one or two things that is beneficial, and I hope if there is any shortcomings, it is from me. The best of it, I hope that is beneficial to everyone. Thank you so much for this unique, for your time.
Yeah, thank you, Dr. Akem, for nice presentation and very good knowledge. And okay, so we may open the question and answer. Okay, but due to time constraints, so we will limit our question and answer up to 3 people for each speaker. Okay, so you is there anyone wants to give a question? So, sementara ini kita batasi dulu ya, karena waktunya terbatas. Kita batasi untuk 3 penanya untuk masing-masing speaker. Okay, while waiting for question from our participants, currently we have 2 questions at the chat room for the first speaker, for Dr. Sophea. Is Dr. Sophea is with us?
Yes, I'm here.
Okay, thank you, Doctor. Okay,
Yes.
so currently we have 2 questions for you. Yeah, from the first question from Suchili. Okay, the question is, some people say that AI is a plagiarism. So what is your option about that? I think it's what is your opinion about that? That's for the first question. Maybe I can give you the
Yes, I didn't get the question well. So, what does it mean by the plagiarism here? Can you elaborate a little bit more?
Okay, so maybe we can ask Mr. or Miss Suchili. Maybe you can ask the question directly to the speaker.
Itu maksudnya plagiat, Mas, plagiat. Jadi apa? Kayak dia kayak apa? Menjiplak gitu. Penjiplakan. Ya, plagiat.
Penjiplakan dari apa?
Ya, itu misalnya kan kita ada suatu program, kita kan pakai AI. Nah, nanti hasilnya itu dibilang plagiat gitu. Hasil dari AI.
Okay.
Ya.
Okay. So maybe we can translate it to Dr. Sophia. Mr. Sujiti said that the product from the AI can be considered as a plagiarism. So what is the option or the opinion about that? That is his question, Dr. Sophia.
Sorry, actually the sound is not so good. Can you clarify the?
Okay. Can you clear my can you hear my voice clearly, Dr. Sophia? Hello.
Sorry, I was disconnected just now. Can you please clarify the question again?
Yeah, okay. The first question is from Mr. Suchili. Yes, he was asking that with the current this is the question, the elaboration of the question that he gave just now. So what is the whenever we use AI and artificial intelligence for any sectors, and then we have the product from AI. And sometimes the output from the AI is considered as a plagiarism. So what is your opinion about that? That's the first question from the Mr. Suchi Lee.
Mm. Okay. Okay. Let me try to answer to these questions. If you talk about this plagiarism, I don't know if you refer to the current ChatGPT, which is a generative AI that can generate a certain
Yeah, bad connection, I think.
I think yeah, that, she is disconnected.
Okay. Sorry, my connection is not so good. I hope you can hear me now.
Yeah. Maybe you can repeat a little bit. Just now it was connected.
Okay, so if you refer to ChatGPT, yes, of course, they have a certain concern about this current ChatGPT, which is the generative AI, that may generate some plagiarism.
Yeah, I think it's disconnected again. Okay. Hello, Dr. Sophia. I think she is experiencing maybe lost connection. So maybe we will give it time for her to recover the connection. Okay, so I think we're waiting for other response from her. Maybe we can go to question for Dr. Akim for what? Yeah. The question is from the chat room as well. Yeah. From Mr. Sujili as well. And he said that how to solve this limitation in facing non-technical problem.
Yeah. Okay. Thank you very much for the question. I think you have some background in trees. That's why you can ask that question. Initially, when trees was started, it was focused on engineering problems. So technical, highly sophisticated engineering problem. But along the line, as you rightly mentioned, people started to wonder how we can use it for management problem. We can use it, but not in all cases as far as it has been implemented. So people are actually adapting it to so many areas as it evolves. So we talk about customer service, we talk about organizational structures and so on, issues like trimming, like and so on. So, but this will be depending on those who wants to use it, how, to what extent they understand it, how they can adapt it. If you look at my own analysis just now, I was looking at ideal problem, ideal solution, and I was looking at how we can train people better. So my ideal system will be a system that actually involves students in the real application. So if you are looking at medical school, the medical students, they do maybe first year, second year theory classes, they do lab and so on. But immediately they get to third year, fourth year, they started to do clinical, meaning that they treat patients every day. So if you teach computer science students to do the same thing, develop application every day for next 2 years, when they graduate, definitely they will be good. That is the idea. So it depends on the team that's actually using it. It has been adapted to a lot, but like you observed, it is more easier. I'll put it that way, easier for technical problems, because that is where it was focused in the beginning. So that is what I would say. But it's evolving. So you can be some of the innovators too, and then create some of these ideas by yourself. God willing, inshallah. I hope my explanation is okay.
Okay, thank you, Dr. Akem. Yes, I think now we have Dr. Sophia again with us. Hello, Dr. Sophia.
Hello, can you hear me
Yes.
now?
Yes, I can. We
Sorry
can hear you.
for the internet connection problem. Okay, so answer to these plagiarism questions. I'm still not so sure what these questions refer to, but I will try to answer to the question. So if we talk about this recent ChatGPT, which is a generative AI tools that allow you to generate text based on a certain training models and data. So of course, those generated text is have a certain levels of copyright because it was generated, of course, from others authors or others articles. So how to handle this plagiarism? There are, of course, certain tools that we're trying to develop and to counter check the text that generated by ChatGPT or similar tool. So that is one of these solutions. But another solution is also to educate all the learners or researchers or scientists to be aware of what we call or what can we call the academic crime, what can we use and what we cannot be used from this ChatGPT itself. Yes, so of course this generative AI can raise a certain concern in the academic perspective. To solve this problem, I think the only solution is to raise the awareness to all these researchers and academic to which extent they can use the tools itself. I hope that answered the questions, or otherwise maybe you can clarify again your questions.
Okay, thank you, Dr. Sophia. Actually, there is another question for you, also from Mr. Hadian. So he asked about how can we evaluate the performance and the effectiveness of machine learning or deep learning models in solving a specific problem domain.
So that come to my fourth point, right? How to evaluate. So first of all, you will need to build a standard benchmark. So those benchmarks should contain the data that is close to the reality. So let's take an example. If you want to evaluate a system that focus on cervical cancer cells detection, so you need to have a certain benchmark of the real data, so the data that collected from the real patients, with the annotation from the expertise that will annotate the data, which cells are cancer and which cells are not cancerous. And you can use those data to evaluate your system. So the system are evaluated on the real data. And then how to calculate the average or evaluation confidence? You need to choose a certain metric for evaluation. So let's say if you want to focus on accuracy, so maybe confusion metric can be used. Or if you want to evaluate how accurate your system can detect cells, so you can use, for example, F-score. So there's two things that you need to use for evaluation. So first, which data that you use. So the data must be close to the reality. And then which metric or which algorithm you use to evaluate your algorithm. So that must be chosen wisely also. So it will be really depend on each problem. Yeah. So I hope that answered to your questions.
Okay, thank you, Dr. Sophia. Maybe Mr. Hadian can get the answer. Okay, is there any question from participant here? You can raise your hand. Okay, so we have I think that this will be last question, yeah, at the chat room. But Mr. Johannes Ali, so maybe you can tell us to which speaker that you want to give the question.
Yeah, good afternoon. I see your blog chat, I never see your feedback. I confused about the artificial intelligence. How to work the AI, because generally input should be the output, should be the feedback plus on main make the clever the output. I confused with you because my background is the electrical engineer. Jadi of course I know the output, closing output, and so on. But I confused about the presentation before. I never see the feedback for the diagram. How to use it? Please give me cleaning.
Okay, so maybe Dr. Are you going to give the question to both speaker or to any specific speaker, Dr. Johannes? Mr. Johannes Ali?
Yes, I use the SP, and I put an SP. If I repeat again, if the have the input data like the doctor just have sheet for data and give the input, but input it going to output, for the result output, but the result output never feedback to input again. I confused about this because generally if you see and maybe last time book maybe analysis of the linear traffic catching is analysis of linear. You should have the forward and reverse on here for make the result solution. I confused why you don't have the forward and reverse about the artificial intelligence. Maybe doctor give me the information more.
Okay, thank you so much, Pak Johannes Ali. So maybe the question can be answered by both of our speaker. Maybe I give the chance to Dr. Akem to answer the questions, maybe.
Actually, I don't get the question, to be honest. But maybe he was trying to use reinforcement learning, where the output of one stage is actually the input for the next stage. Maybe that's what he's talking about, but I'm not quite sure but maybe he's using models like LSTM and the rest of it. I'm not sure what he's really talking about. But maybe because of time, you can send those questions to Dr. Sophea and also probably to me. If I can get the question properly after it's typed, maybe I'll be able to get what he's talking about. Closed loop system.
Okay.
Oh, okay. Let me see.
Oh, okay. I think I will share the same thing. I'm not quite understand about the question, but I will try to answer to this. So likely he was talking about how to use output, result, and input data, but we never see your feedback system. Yes.
Yes,
So
yes, right. Yes.
Okay. He maybe talk about reinforcement learning, but I also try to explain this. So normally, before we release a certain system that based on AI, a good developer or researchers need to do proper evaluations and testing to ensure that the system have a certain level of confidence, and the report of confidence need to be clearly stated also. So for example, if you say your system can recognize a certain thing up to 95%, so that means the data or the system was experimented on this proper data that gave this number of accuracy. So that is one. And Again, if you talk about reinforcement learning or monitoring output of the system, and I think, of course, from time to time, such an AI system will need feedback from the expertise, and we'll need this closely monitoring and improvement from the engineering or researchers themselves. So just get back to my point. So each and every system needs to be developed, but also evaluate with the right benchmark using the right algorithm. And each system, when it has been deployed and used, so it need to be also monitoring closely by this engineering or researcher team, so to make sure that the result given by the system is still accurate based on their report. Yes, so that can be my first answer. And again, we're not so clear about the questions, but I just try to answer to the question. Yeah. Okay. Thank you.
Thank you, Dr. Sophea. This is good. It's right. Your talk, right? I understand. This is right. I agree with you. Thank you.
Okay, thank you so much for the question and also the answer from both of our speaker. Is there any other question from our participants?
Yeah,
Okay,
the
so
new
if
question,
the
box.
okay, go please, Prof. Teddy. Do you
No,
have
there is no
any?
question. The new question inside of the chat box
chat box
from Cambodia.
I think that, oh yeah, there is another one question. Okay, this is I think for Dr. Akem from Mr. Ying An from Cambodia. I'm sorry if Mr. Or Mrs. I'm not sure. But the participants asked about, okay, excuse me, sir, I would like to ask you a question. Is trees different from brainstorming? And about trees and brainstorming, which one is better for engineers?
Well, thank you very much for the question. Of course, they are different, but generally in life, brainstorming means that we think about a problem and ask questions and try to propose solutions. That is what brainstorming is all about, though there are a number of tools that you can use to do that. But in every problem that you try to solve, there will be at some point some element of brainstorming. There's no doubt about that. But trees is a set of methods that is used to solve problems. Maybe I can, if the time permits, I can quickly look at the combo for solving problem in trees. Let me see. So it's completely different from brainstorming because it's a set of tools on its own. And the method is actually used to guide solution. If you want to provide a solution, instead of thinking in different direction, you already know how to start and what direction to go. But like I said, there's no perfect system. So we have to know that. But the thing is, it's a guided way of looking for solution. That is what trees is all about. If I can think, okay. So this is the slide that I showed at that point. When we use, maybe I can share quickly. So when we use brainstorming and other approaches, if you are thinking along the right direction, you will get to the solution. If your thinking is on the right, then you are going to the solution already. You may get the solution. That is the structured approach because you already have a way of thinking. If you have brainstorming, we have 5 members of the team, and one of the members is the outspoken person among them. Most likely, people will think he is smarter than the rest of the team. If it's in the right direction, then we are likely to get the answer. If it's in the wrong direction, we are going in the wrong direction. Maybe somebody that is quiet is actually the one that has the solution. But TRIS is going to make sure that all of you are guided. You cannot go out of the solution. First, you have to define the function of what you want to do in simple terms, layman terms, and then you go on to the cause and effect analysis. And then you can trim. Trimming means that you reduce the components that is redundant as much as you can do, is possible. And then you analyze the S-curve. What is the stage of this product or of what we want to do? So guided to the, if everybody is brainstorming, you are in the right direction. That is what it means. Only in exceptional cases that you'll not be able to get to the solution. Okay, so, but brainstorming can diverge. If you are not thinking about the right solution, you can actually diverge out. That is what the idea is all about. So maybe if we have time later on, we can actually explore it more. Thank you.
Okay, thank you, Dr. Akem, for the answers. I think that is the last question. Yeah, before we close this session. Okay, thank you so much for coming on, all the participants, and to both our speaker, Dr. Akem and Dr. Sophea. But before we close, maybe we can have a conversation. Please, you may open your camera. Okay, then we will be having. Yeah, Prof. Teddy.
Can I have a close remark?
Okay.
Oh yeah. Photo session first or remarks first?
Oh, that's okay. That's up to you. That's fine.
Okay.
Yes.
Okay. So I think while with people still preparing the camera, so maybe you can have your closing remarks first, Prof.
All right. Okay. So, okay. Thank you, Dr. Haris. So, everyone, we're running this type of webinar since 3 years back. So every single series actually we're running around 10 times. But last year we're running only 6 times. All right. This year, these times we try to running it around 10 times again. Yeah. Hopefully you can join for every single 2 weeks of our webinar. Before we talk about the next webinar, number one, I want to say thank you really to Dr. Sophea about the explanation, yeah, quite details about the AI basically, yeah, the background of AI. Just for your information, Dr. Sophea, the first our webinar we talking about the what you call it, the transformation, especially also related to the curriculum, not only in computer science faculty, but also in outside of that faculty, in relation to the transformation from predictive AI that you explained it just now, goes to the generative AI. Whereas a lot of people around the world, the case from US, for example, the case also from the UN, UNESCO especially, they collect around more than 40 Minister of Education. They're talking about how we prepare in terms of the ethic when, for example, certain countries they want to use the generative AI because some dangers in the back of that. Yeah, so we discussed it already in the first webinar at that time. And just for your information, everyone, our School of Computer Science of Nusa Putra University, we got a good project. Let me share about the project briefly. This already running since last August, and then last January was considered as running well, already used by a certain office. I cannot reveal the name of the office. Dr. Ramadia is here, Prof. Media is here, and with me, and also with some other good students, we are running this kind of project. So I try to emphasize what Dr. Sophea mentioned. Data is very important. All right. So what happened in Indonesia, according to AMSI is the association that related with the media online, especially in the cybersecurity. Yeah. So they call it AMSI. So in Indonesia, we have around 443 media online that are registered under that organization, meaning that they should be registered under the journalist of formal journalists, and then they need to register that they are working in the specific area, which is cybersecurity. So what happened in our approach, we using cron job, we using some way to scraping every single media online. As everybody knows, the CSS is not standard. The way we're reading of every single website is also not standard. So we need to develop our own, and we check when, for example, some of the collection of the data from the website doesn't work well, for example, then we need to see what kind of error and how we fix it. So currently what happened is every single minute we collect around 110 of media online, which is quite huge. All right, and then of course we need a very special server. We running it until they got the good thing, and then from there we do the cleaning and so on, like what you just mentioned just now. And then the next level that we do at the times, sorry, not running at the moment, we try to find what is the best solution to do the categorization. Please remember, if you have the very huge data, and we want to use, for example, some of them to create them certain model, then we need also to verify. For example, the first instance we need to labeling around 100% of certain data, and we divide 80% and 20% or 30% and 70%. We try to find what is the best method that we can have. Of course, several deep learning is a good approach, but quite slow, for example. So we need to have some more practical thing. And what happened here is we do like 3 levels of categorization. For example, the first categorization, we have 5. Something in Indonesia, we call it as Ipolexos Buthankam. So number 1 related with the ideology, number 2 related with the economy, number 3 related with the politics, for example. Number 3 related with the social and culture. And the third one is about the pertahanan, what do you call that? Some related with the security stuff. So the first category, every time we got the new data, we categorize the first level to goes to the one using AI, of course, to do the categorization. And then the next level, if they goes, for example, to the politic thing, they have other categorization. So in total, the first one we have 5, and then the second one we have like some loop or do another different categorization. We have like around 82 to be exact. All right, from the 82, Dr. Ramadia is here. He's who developed the coding, by the way. He's also the lecturer with us. And then the next one, we have like 4,097 categorization. So I can say like we have some first category, the second one is subcategory, the third one is about the what you call it, about the issue, the topics. For example, in Indonesia currently we are in the situation that the election will be happen next February, and then this coming March, for example, the new candidate will be announced. So a lot of issue there, a lot of things in relation to the so the part will be the politics, and then goes to the another sub of the politics, and you're going to see some other subcategory number 3, which is around, say, for example, 200 type, and one of them was the election, the pemilu. So we try to see what is the current problem that we have. So we call it as the 3 level of the classification. Currently still running. So I try, when I explain this, I try to answer also in this case, in this discussion about the evaluation. All right. So when we create a certain model, of course, the model, we have to guarantee that the result should be greater than 80% correctness, right? So in our case, we have like nearly 93. But this is the case. After the times move, go to the next month, the month after that again, and so on. So what happened is we need to do some evaluation, whether the model still give the good result. All right, still give, for example, greater than 80%. So we need to do the evaluation every time. When the evaluation going down, so then the time, that will be the time for us to develop the new model. they'll be running until in the end of the system. When we develop the system, the most important thing here is the user, because we have to make sure the user will use the data that we giving to them, the output that we give to them, we give it to them, they have the right output, and the system is running until now, by the way. So the future for this work at the moment, we're not working only in the media online, but we goes to the social media, from Facebook, from TikTok, and so on, which is not simple. Basically, when we're talking about the systematic, repeat again, unstructured data, for example. So I just try to explain this loop for developing the application and the evaluation also. And then the second one to Dr. Akem. So thank you very much. I'm proud of you, Dr. Akem. The way you think now, quite different after several years getting the PhD. Especially when I see a couple papers from you, when you working in, where is it, the university? I forget the name now. Before you joined IUM.
Unimas.
Unimas. Okay, somewhere over there in Kalimantan,
Yes,
it's very nice experience, I believe. Very good. So I saw the recommendation system was proposed by you also at the time. So when you back to IUM, there's a hope actually from my side, Dr. Akem. Remember, you are a part of the Intech lab. We have a very nice lab at the time. We win a lot of competition. And in the same time, I try to answer from Pak Hadi just now, how to solve trace limitation, especially from for the what you call that, the problem of non-technical problem, especially in the organization and the management. So let me emphasize this and listen to Intech Lab, which is not there anymore. So if that possible, please, Dr. Dini also there. So if you can lead and develop you can change the name, but the spirit should be there, right? So what we need is actually from my side two things, Dr. Akem and Dr. Dini, especially Dr. Akem in this case, okay? Because this our webinar goes to Dr. Akem. He proposed about trees. Maybe you can use it, the trees, in the new Intech Lab in the near future, all right? So I emphasize two things. Number one is this on how to solve the organization and management. Okay, we need a leader with a good strategy, all right, and then also with good authority. So you need to have some, I think I don't know now, but before we have the faculty meeting and we can propose a research group, for example. Because when we have the good guarantee from them with the letters from them, then we can run formally. Okay, and then we need to think. Number one is authentication. The second one is the second one is we need the budget, of course. That's why at that time, like in my case, or Dr. Media at that time, Prof. Media, Prof. Murni now. And also me, myself, we apply every single time to get as much as the funding. Until at that time when we have a good funding, if you go to Kuala Lumpur at that time, we hire the programmer a month for 200, 2,000 ringgit. But at that time we can hire until for 1,000 ringgit a month at that time. Why? Because we have funding and we have a strong and good problem set. So that's the strategy. I think the first one is we need to have the strong leaders with the strategy, with the good funding, with the good authority, and so on, right? And the patient, of course. All right. Second one, of course, the member of the lab. You need to find a good brain. You need to track a good brain, like what we did at that time. I hope you still remember the ICM SCPC programming thing. So some of them I invite them, but some of them they hunting to us. They want to join us basically. So one, you have the good brain, you have the good product. So some PhD students, some master degree students, they're going to sit together with you in the lab. Then I believe then when you compete with others in Malaysia, then a lot of reward will come to you. And that's my comment from your current situation, also the question that raised by Pak Hadi just now. Okay, and then the third thing that I want to mention before I close here, I would like to thank to Dr. Dini who approached Dr. Akem and also Dr. Sophea. And also, she is the coordinator from this webinar until 10 times. Usually we communicate with Dr. Dini and also with some admin staff and handled also by Prof Media. So hopefully we can running this together until in the end of the 10 times of our webinar. Just for the announcement at the moment, everyone, the next webinar 2 weeks from now, we're going to discuss the approach that we discussed previously 2 years back about systematic literature review, because at the times we surprised the systematic literature review can jump in, even goes to the Scopus Q1 journal, right? And I saw like Dr. Dini, one of the experts that we have, I think when she was in Tyler University also, she already used that kind of approach. And couple of the students of Dr. Dini with me also, the alumni from us also, from IIUM at the time, Alahak, for example, he got couple paper that accepted in Q1, which is quite nice. What does it mean? Meaning the background is strong, meaning the SLR is working there. So then 2 weeks from now, we are going again to introduce the structured literature review. Hopefully Dr. Dini will be there and also Prof Media will be there, yeah. And the case we're going to choose the AI cases, especially for the AI that we are going to use in the near future by using the generative AI, for example. All right. And I still remember the first question about the plagiarism. Yeah, I think the direction from Dr. Sophea was quite nice, because someone, for example, as the what you call it, as the researcher, they generate the text from generative AI like ChatGPT or others a lot. Yeah, by the way, some of the application even they can create the summary, good summary, and then you can create also some paper even with the good literature, with all good thing. Yeah, this is not new also, by the way, in our area. But the thing is, when you put it in the paper, the couple software like Turnitin now, you can see directly not only the level of plagiarism from the reference, but also the level of plagiarism from the generative AI. One of the weakness from the, I think I have a couple of students at the moment from Universitas Pertahanan, UNHAN, IDU, yeah, Indonesia Defense University. Couple of them, they publish paper together with me. Some of them now sitting here. Some of their paper, we identify small number, yeah, only a small 1 or 2 paragraph basically. She or he, maybe they generate using the ChatGPT or others, and then, or maybe not also, but the pattern is the same. Really unfortunate, when they use the Turnitin, the Turnitin can find that the text actually they came from the some kind of generative AI. All right. So then what we need to do? That's very simple, everyone. So if we see only 1 or 2 paragraph, that's very easy for me, from us, just delete it and write the new one. All right, with the new idea, of course. We have a bunch of idea in our mind. If there is burdening us, then we just remove it as easy as it is. Yeah. So, but of course, the original work there will be more. Of course, we can learn using all the generative AI that we have here. All right. So, as the last part, I would like again to thanks to the all audience, especially from the member of the IEEE-CIS Indonesian chapters and IDNNS also. And I saw also the Sekjen from AI, Pak Siswanto. Thank you, Pak Siswanto, to be here with us also. And also some of our staff actually, and some friend also from UNHAN, some friend also from Undip. I saw a couple of my students also doing PhD with me. Pak Robi, for example, he is also here with us. He also got the Q1 Scopus journal. I think very soon he will get the PhD also. And then, of course, the member of SoCS, and of course, with the most important thing here is the IEEE-CIS Indonesian section. My last part, yeah, everyone, let me share with you one of the website that I want to share with you. Just in case you want to see Dr. Dini physically, directly, and also Dr. Akem. So please come to our conference, apply, submit your paper. So this is the website. All right, this is the number 9. It's already got this conference already indexing under the IEEE, and they got the SGR also. So if you are the faculty and you submit to this conference, the angka credit, the point is not only 25 but 30 now, because they got already the index. So this will be happen on the, like I mentioned earlier, on the 7th and 8th of November in IIUM in Dr. Akem campus, and Dr. Dini campus also there. All right, and this is all the previous conference and so on. All right, this is the due date. This one, I believe they're going to be extended if you're not ready yet. But if you're ready, please submit it. All right. So this one also sponsored by us, by IEEE Computational Intelligence Society. All right. This is the registration fee and so on. This is all the committee, by the way. So I think that's all from my side. So again, I would like to thanks to Dr. Sophea and also to Dr. Akem. I hope you will be available when we invite you, like Dr. Haris already mentioned, to join us as the guest lecturer or maybe supervising a couple of our School of Computer Science student. Oh, give me 30 seconds more, Pak Haris. Let me share with you about our website, yeah, our SoCS school, our school. So just a moment, please. This is a little bit slow sometimes. So let me, yeah, it is coming. Okay, sorry, I'm not prepared. This just happened in my mind that maybe I need to share with you, everyone. So this is our event. Yeah, if you click, you can see the detail of it. This is the second webinar 2 weeks ago, and this is the first webinar, right? This is last year. This is not complete set, but 2021, you're going to see a lot of webinar we're running previously. All well documented here. If you see our research, I believe Dr. Akem will familiar also because he used to be in our lab before. So we become 2. This school running by us, and Dr. Dini, Dr. Ramadi, and a couple of them was here, and Prof. Media also here. So if you see, for example, AI here, this is the detail of our work. Oh, I don't know what happened here now. It doesn't work when I click it. You see this one working well. All right, this is, we interest with the disaster emergency route to use augmented reality. Using Star and Dijkstra, but Dijkstra is simple algorithm, but we running it swarm, so sometime until million times. So if in the normal situation, you can see a couple demo inside here, by the way. Oh, this coming now, so you can see this is the detail. So if you click here, you can see the demo. All right, this is the navigation. Dr. Akem master degree level and PhD before talking about the tracking user location. So this one also, you're going to see the another direction from the work, yeah, location authority and so on. Okay, this is face detection, and then this is the detail with the deep learning. This is our first batch that graduate, I think 2 years back. So a couple of good work already there, but I don't have any chance to put it here. Some good work also in related to the cybersecurity also here. Yeah, so you can see a couple detail of it. How we dealing with the malware in Indonesia, especially. Yeah. So if you see our profile, you can see a couple of the lecturer here. Some curriculum also, we develop 3 types of curriculum. This is the combination between AI and cyber. For example, down here is concentrated in AI only, and the last one is concentrated with the cybersecurity. Right, and all the lecturer was here also, by the way, everyone. So we have a lot of international students also. So every single year, usually we prepare some scholarship for a master degree level, but not from local. Really unfortunate, we have a limited budget at the moment. All right, so yeah, I think that's all of my introduction about our school. By the way, everyone, what I'm trying to say is this event initiated by like 2 or 3 entity, basically the IEEE-CIS Indonesia section and also our school here. All right. And our class all in English, and then at the moment we're running hybrid, but because of the pandemic, we're still running online at the moment. So I think some of you already knows about this. So I think that's all from my side. So let me send back to Pak Haris. Haris, thank you, Pak Haris.
Yes, yeah, you're welcome, Prof. Teddy. And thank you for the closing remarks. And before we close our session, so please turn on your camera. So we will be having our photo here together. Yeah, and okay, so I'm giving like maybe 1 minute to prepare. Yeah. Okay, so are we ready? So there are 2 pages. Yeah, so please post your base best post and okay. So I think we will take from the first page. Yeah. Okay. 1, 2, 3. Okay. So the second page will be okay. 1, 2, 3. Yes. Okay. So okay, that's all for the session. Thank you so much for coming, all the participants and all the speakers and all the committees and many other parties that I'm unable to mention one by one. So hopefully this webinar session can give us bright knowledge and better understanding about the AI and systematic innovation. And don't forget, so in the chat room, okay, there is a link for registration to our master program at Computer Science School of Computer Science. Yeah, so we are waiting for you to be part of our member at Nusa Putra University, especially at the SoCS. Thank you so much. Have a very good night, and wassalamualaikum warahmatullahi wabarakatuh, and have a nice